It's a great morning, and hello and welcome to the third webinar in the series of national initiatives, webinars which is being organized and moderated by the project SNS Co-op. In the past, we already have had UK and the Netherlands present their initiatives, and today we are glad to have the stage set for the Italian National Initiative on 6G Restart program. The goal of this webinar is to give the floor to the national initiatives to share their achievements and highlight their key results so far, and also position themselves strongly in the European research ecosystem. To open the webinar, I would like to give the floor to Colin Wilcock, who is the chairman of the board of the 6G IA and vice chairman of the board of SNS JU and vice chairman of the board ETSI. So with many hats, I present Colin Wilcock. Colin, the stage is yours.
Thank you very much. Thank you for the kind introduction. Well, it does sound like I've got a lot of things to do, but let's put that to one side at the moment. So welcome everyone. I think this is a really important event. And I guess the importance is really related mainly to things we're all aware of in the news and the geopolitical situation and everything. We see that we have a new commission in place. We have things like the Draghi report that's saying Europe has to work together to be competitive in this very competitive, ever more competitive world. If we are going to compete with China, with US and with other players, we need to work together. And I see this event today as a sort of first step in this direction. So we have various different instruments in Europe funding connectivity, mobile communications. We have national programs like the one that we will hear about today from Italy in many European countries. And we have at the European level things like the SNS JU, but also other activities like in IPSI and also some in Celtic. So there's a whole series of activities going on, but in the end, what we want is one European proposal. We want one 6G standard. And to get the most impact, most leverage from Europe, we need to work together. And that's why this event is so important today, a chance to understand what is going on in Italy, see the important work that's going on, but then try beyond that to try and link that together with other activities in Europe, be that at the national level or at the European level. And clearly the hope is that the more we can link things up, the more that we can make use of the fine research in places like Italy at the European level, the more value there is for Europe and the more impact from that work in Italy will be. So with that background, thank you very much everyone for taking the time to present today and listen today, and I hand back to the moderator.
Thank you, Colin, and to give us this glimpse and also to motivate us to have one voice, and so that we all can come together to this one 6G initiative. With that, and without taking much time, I would now like to hand over to the Italian National Initiative to Antonio Copin to give an overview of the Restart program.
Thank you. Let me share my screen. Okay. I hope you can see my screen.
Yes, perfect.
Great. Thank you. So good morning, everybody. My name is Antonio Capone. I'm professor at Politecnico di Milano Technical University, and I'm also the scientific coordinator of the Restart program. I will give you today a brief overview of the program, and we will focus all together as program in this webinar to presenting you in particular the experimental facilities and labs that we have created that they can also be used as an asset for stimulating cooperation at European level. As you can imagine, you know, the national initiatives have been shaped strictly depending on the rules that each member state has applied for the definition of the research programs. In Italy, this has been done with an instrument which is the Italian National Recovery and Resilience Plan, where in particular the Ministry of University has defined some rules for identifying 14 sectors that are relevant for the national economy for stimulating research in Italy. And you know, among these 14 sectors, there is telecommunications. This was not you know, something that was given for granted at the beginning of the process. But we were particularly happy that our sector was selected for one of these initiatives. We are organized with an hub, which is the Restart Foundation. We have 8 spokes that are administrative entities, and the total grant that was provided under this instrument is 116 million euros. The duration is 3 years, so this is the last year of the program. At the beginning, the program has been proposed by 77. There is probably some echo. Can you mute your mic, please?
I think this is.
I don't think it's for me.
Yeah,
okay,
now
it's fine. Yes. So we have 17 partners that joined the program since the beginning, actually during the proposal phase, which include you know, several universities and research centers and some of the major players, industrial players in telecommunication sector in Italy, operators, and vendors, and consultants companies. In addition, this was again part of the instrument, how it was shaped. We had a number of cascade calls, and additionally 89 partners joined through these cascade calls. So now really we have a very large number of partners in the program. They represent basically the entire Italian sector on telecommunications, and also a number of players that are on the application development that are, you know, based on connectivity as the main instrument. As I was saying, we are organized in 8 spokes. These are administrative entities for managing the program, but they also act as you know, points for concentrating the activities and orchestrating the activities, in particular, as we will see today, regarding the experimental facilities and labs. The program is not only on research. So of course, research is the main mission that we have, but we have additionally 6 other missions. One is the one devoted to the creation of national laboratories and the support for a proof of concept and demonstrators. Then we have a specific set of actions for innovation and technology transfer, support to startups, education, PhD programs, and of course, communication, standardization, and open source solutions. Inside the program, we have 32 research projects. These projects are really covering the entire area of telecommunication. So the rules of the instrument that we have been using basically guided us to be really broad in the scope of the program and not really focused on 1 or 2 specific directions, considering also the size of the grant. I will not, of course, list you all the 32 projects, but you have to consider that each of these projects has the size, more or less, of a European project, like the one that we are used to in the European Commission. In addition to the project, we also designed some cross-project initiatives that we call Grand Challenges, in order to stimulate cooperation among the projects and also the specific attention to some dimensions that are, for example, sustainability, open source communities, and other directions. So this has been also an interesting instrument for creating impact and stimulating, the different research teams in the program to cooperate and towards some impact creation activities. We recruited a total of more than 350 researchers in different stages, from PhD to assistant professor level. And this is one of the important assets that we have been creating with the program. Of course, then the future of these young researchers is part of what we are interested in stimulating possible cooperation at the European level and making them part of the larger European community of research in telecommunications. Of course, on the website, you can find many KPIs that can describe how we are contributing to research and how we also are implementing a specific action for outreaching a larger public. I think we are reasonably good, going well, but of course, you can figure out yourself looking at the website. I invite you to take a look. Coming to the specific focus that we have today in this webinar, with Restart, we have created a number of research laboratories that are open laboratories where members of the Italian community can start activities and use the instruments available. They were being located in the sites where we have the 8 spokes. There is one exception because there is one spoke in Pisa that has 2 labs because of the specific topic that are covered in the 2 labs. In addition to these 9 labs, then we have 4 associate labs that have been collaborating with Restart. They are pre-existing labs that have a strong connection with the program. So this is the reason why they've been opened also to the larger community of Restart in this specific program. I will give you a very brief overview of these labs, and on some of them we will have a specific focus with the 3 talks after mine. The first one is a Phonet lab. This is located in Pisa at Scuola Superiore Sant'Anna. Piero Castoldi will be one of the speakers after me, so Piero will present you more details regarding this lab, which is devoted to optical network system and devices. It has a number of technologies that are part of the instruments and test beds available in the lab, and a number of goals in terms of innovation, from optical network validation to peak design. The second lab in Pisa is located in the CNR, National Research Council in Italy, and is focused on large-scale infrastructure for experimental studies. So it's network level, and the main focus is on disaggregated networks and edge computing. The lab in Bari is dedicated mainly to non-terrestrial networks and integration of non-terrestrial networks and terrestrial networks. It has a number of again technologies involved, from drones to, of course, non-terrestrial networks, and a number of emulators that are available for testing solution dedicated to non-terrestrial networks. The YCNet lab is in Milano, and it's focused on wireless system and network technologies. Again, we have a very large set of technologies involved, related mainly to high frequencies, but not only, and the number of instruments for measurements and operating between 3 and 110 gigahertz. We also have radio and optical systems for creating specific testbeds. And again, the innovation directions are in the direction both of the transmission technologies and that of the new network architectures. The Prognos, the Prognos lab is in Torino. Carla will also present it in the next talk. the focus here is on programmable networks, and it has also a part dedicated to new media. So these are the main two focuses. So the creation of a platform for experimenting programmable interfaces in the network and platform for orchestrating network functions. And on the other side, that another part is on how the new media will impact the network in terms of information transferred and support required by the network to the network. The lab in Bologna is focused on industrial networks. Of course, industrial networks are very specific in terms of the application domain. You have different types of technologies that are involved, including those that are covered by the other labs. However, the focus of this lab is really associated to one of the competence centers for industrial networks in Bologna, and it has a number of facilities for the prototyping specific solutions for industrial applications. And again, they include UAVs and AGVs for as instruments that are common now is in several industrial domains, and the connectivity that you can have with different technologies. The lab in Catania is dedicated to mission critical communications. It has a number of collaborations also with other sites in Italy, including the University of Padova. They are working again on a number of technologies, and they have support in the lab for these technologies that include not only the classical IoT technologies, but also underwater communication devices, and in particular there are a number of activities also dedicated to the area of underwater communication. The Fabris lab is in Naples. It has actually two components. One is dedicated to joint communication and sensing, with all the instruments associated to the experimenting with this new domain in research that will be, of course, very important for 6G standardization, and also smart propagation environments with a specific instrument dedicated to the fabrication of, for example, RIS and other type of technologies, including smart skins. The lab in Rome is in the University of Rome Tor Vergata in particular, and it has a specific focus on artificial intelligence. It has a number of very diverse instruments for prototyping networks, and the goal here is not that of working specifically on network technologies, but more on creating platforms for experimenting then on how artificial intelligence algorithm can be used for the optimization and customization of the network functions and the network operations. Finally, as I was saying, there are a number of affiliated laboratories. In particular, there are 4. There are 2 in Milano, Polyfab and the Photonic Devices Lab. Polyfab is a facility with wide chambers in Milano, dedicated to the micro and nano fabrication of different devices. In particular, the lab, the team working in Restart in this lab is working on the fabrication on integrated photonics devices. And this is the reason why there is also the other lab, which is this photonic device lab, where the prototypes are then characterized and tested. The other 2 are one in Pisa. Again, the goal is here on prototyping, packaging, and the other one is in Genova. And in Genova, there is a new lab, very recent, which is dedicated to the creation of network platforms so that can be connected at national level with others. So I will stop here. Thank you for your attention. And now we will dive in 3 of these labs, We will start with the one in Torino with Carla Fabiana Chiaserini. Carla, the floor is yours.
Thank you very much. Let me share my slides. Perfect. So yeah, thank you again. I'm Carla Fabiana Chiaserini, Politecnico di Torino, and along with my colleagues, recent Professor Magli, we are part of this great Restart initiative. And as we will see in this presentation, we have set up a lab called Prognose, as Professor Capone already introduced. So there are 3 projects, the Super Famiglia e Leggero projects, that are part of this research initiative at Politecnico di Torino. We are, of course, participating through these research projects and experimental activities, but I would like to mention that there are several other colleagues that are part of other universities all over Italy that have been involved in this lab, and also through the cascade calls that Professor Capone mentioned. So let me thank, of course, all the participants to this lab at Polito. Also, this presentation today will focus in particular on the topic of programmable network platforms, but as I said, there are several other research activities that we are carrying out within the lab. So this is our historical premises in Politecnico di Torino. Beautiful, but don't be misled, because we have, of course, advanced equipment in our labs, as exemplified in these photos that we took. And as you can see, we are experimenting with programmable networks, programmable devices, and services that aim to be extremely distributed and composite. That means they are composed of multiple microservices, and most of which are intelligent services, so based on machine learning approaches. Here you can see, of course, drones, networking equipment, and also what we use for our vehicular network and vehicular network applications and services, and we'll spend a few more words on that. So let me just summarize the main challenges and goals of these research initiatives at Politecnico di Torino. So the idea is that, as indeed we need more and more, and we get used to that, high quality, high performance, uninterrupted connectivity, well, this is of course possible, but poses several challenges that we have to face and overcome, as the also network and service environment is becoming more and more dynamic. So there are changes over time, some changes as well as hurdles that are posed by the specific operational environments, and also cyber threats that we are facing as well and addressing within this project. So the idea is indeed to exploit 5G, 6G technologies, as well as, of course, the use of IoTs of different type, different nature, and, as I was mentioning, intelligence at the edge in order to tackle all these aspects. And our challenge is then primarily to develop networks that are able to configure and be reconfigured very efficiently and very effectively. So resilience is also one of the important keywords here, besides configuration or reconfiguration. It means self-adaptation of our network, as I mentioned, also security. So being resilient is extremely important. Resilience is interpreted here as with respect to network failures, but also, as we're saying, security threats and decrease in quality of service and quality experience that also our users may face. So let's see how we are tackling these challenges more in detail. Of course, through networks that can be programmed, and they can be therefore reconfigured at the data plane, control plane, and management plane. There are research activities along these three main directions, and this is the experimental setup that we have created in our lab in order to develop, test, validate our solutions. So you can see that we have got 5G cells, both, let's say, based on totally open source solutions as well as proprietary solutions. So those are private 5G cells that provide access to the core and then the edge. And we have programmable switches that compose our wired fixed network. And we connected our network through a transport network that is programmable, fully programmable, to other networks as well that are by the premises of partners, but are also by any other university in Italy that can be reached through the so-called GARA internet that connects all the research and academic partners in Italy. So just to give you a few more details on what we have got in our lab and how it works, let me just present this slide. Of course, I'm not going through the details of the equipment that we have got, but just to give you an idea on how our edge computing platform features. And as I was saying, our goal is to exploit AI and machine learning approaches. Of course, we need GPUs in order to make our computation fast and efficient, in particular for the training of our machine learning-based solutions. So this is essentially a view, an overview of the edge computing platform with GPUs and smart NICs that we have got. And I would like to underline that our programmable switches are now open for experimentation to all the partners of the Restart initiative. And here you can see the web page that we created and the URL through which, of course, you can find more information. And our aim is then to open actually these resources to the research community in general. So this is an initiative that we are particularly proud of. And this is the representation of our 5G cells that represent our radio access network. As I was mentioning, we have totally open source based 5G cells as well as private ones. And we are currently experimenting with network slicing in order to support different services. We are in particular interested in services and applications that run at the edge and collect through the RAN data samples that come from different types of sensors. So multimodal data and their fusion at the edge is in particular one of the research topics that we are addressing, also not just through an efficient network slicing, so slicing of the radio resources, but also through the development of advanced algorithms for machine learning based sensor fusion. And within this area of research, we have also been experimenting with vehicles. Vehicles, of course, are nodes that are equipped with many sensors nowadays, so they represent very suitable use case for us and for our research activities. So along with also links, that is a research center nearby Politecnico di Torino, we are covering quite a large area around our campus with 5G cells. And then, of course, they are connected to our edge, and we are complementing this testbed with UAVs, so the drones that can be flown actually within a cage, so that we have different autonomous mobile networks that are connected, and they essentially compose a dynamic network of nodes that are, as I was saying, equipped with several sensors. So this is, of course, in continuous development and progress. And as I was saying, this quite complex radio access network is then connected to the edge. At the edge, we are currently running network orchestrator that we acquired from Nexus, that is one of the SMEs that has been involved, of course, within the Restart initiative, and their product is called Exonet. And we are currently experimenting with this service and network orchestrator provided by Nextworks. This is particularly interesting for us because besides managing and orchestrating radio resources, it has, as you can see here, the possibility to run the ML ops part, so training of models and execution of machine learning models for inference. So we are currently integrating this tool in our testbed. I would like also to actually connect this to the activity that we are carrying out within the Grand Challenge 10, one of the grand challenges that Professor Capone mentioned. This is in particular focusing on network and service orchestrator. We have actually recently released a white paper that you can see mentioned here, open to everyone. It's on Zenodo, and we are describing this architecture that we came up with and designed within a Restart with the collaboration, of course, of all partners. Our orchestration platform is one of the main outcomes actually that we achieved within this joint effort, and it's a platform that follows the service-based management architecture, the SBMA, which is a very prominent design approach defined by 3GPP. So it's modular, it's cloud native, enables orchestration across multiple domains that use multiple technologies. And within the project, we have developed essentially algorithms that fit within each of these blocks that you can see here in this figure. And prominently, we have also this green part where we have the network digital twins and machine learning algorithms and solutions that are running there. So let me just briefly highlight few specific activities that we are currently testing through our Prognose lab and testbeds. So one is about indeed the orchestration for services, and as I was mentioning, we are looking at composite services made of several microservices. And the idea, of course, is to optimize the resources that are used by our services while also maximizing the quality of service and quality of experience for our users. And since the system is dynamic, we need, of course, to configure but reconfigure continuously our services and also the resources that are allocated for their execution. Another important activity that we are carrying out along with also the mobile operators that are involved within Restart is looking at the ORAN architecture and the support of different XApps and the energy efficiency besides other performance metrics of the system. So this is in particular relevant. As you know, ORAN is an interesting architecture and solution. So we are happy actually to experiment with that. And then from the point of view of the transport network, we are focusing also on the use of programmable switches for switches and security threats, how to detect and how to mitigate security threats in our programmable transport network. So let me conclude here and leave the floor to the next lab, but just to highlight again the let's say activities, research activities on programmable networks that we are carrying on, and the possibility that we have and that we hope to open to all the research community for testing and validation of solutions for programmable networks and distributed services. Thank you.
Thank you, Carla, for this presentation of this lab. We will move now to Professor Umberto Spagnolini. Umberto will give us an overview of the lab in Politecnico di Milano dedicated to wireless communications and networks. So Umberto, you can share your slides.
Of course. I think you are going to see the slide, right?
Yes, we can see.
Okay, perfect.
Go ahead.
Okay, so I'm Umberto Spagnolini, professor at Politecnico Milano, and I'm also PI of one of the project, and also responsible of one of the spoke that Antonio, Professor Capone was describing. So what you see here is the Politecnico Milano. This is the old campus, and now let me give another view. So this one is the main campus, old campus here. You see this yellow box, and the department, the ICT department, is located in this corner that you see here expanded. So on the roof of this building, you see many equipments, and now these are different experiments and represent the experiment facility that we have at Polimi, and is also part of the Restart 6G YNet project, and is toward the 6G network. So I need to, of course, the entire 6G YNet is represented by many partners that are represented here. And of course, I have to thank all of these partners that some of these outcomes are due, as a result of the cooperation with some of them. So, I have a short index which covered three main topics, which is, on experimental part. So open air experiments is different frequencies. So we have a different facility in different frequencies that are listed here. And so let's go into detail. So we have a one base station, which is what we call high frequency campus. We have a one base station on the roof of the building. You see this star here. So the base station has been donated by Huawei to two sectors in FR2, 5G New Radio FR2. Is fully compliant, and you see on the other side, you see that the baseband, also the network part, which is given by Hewlett Packard Enterprise, and the spectrum is has been offered by Fastbed for all the experimentation. So within this facility, we have been testing also the upper 6 gigahertz band. So this one is still the same building, which is the DABE, where the department, the ICT department, where I'm staying now. And on the other side, in front, there is, this sector that we have been testing in 2023, so a couple of years ago. And there are several areas where we have been testing, for instance, for shading and covering the coverage in different parts. If you're interested, always at the bottom of every slide, you can find some details about it. So this one is, the main experiment of the 6G YNet is still the base station I was telling you before. We have a backhaul mesh in E-band. We have a V2V connectivity at the bottom. You see that we are testing also in FR2 some metasurfaces, and also we are building together with one of the parts of the network controller repeater, which is an amplifying forward repeater. So one of the mesh of for the backhauling is provided by a single frequency network that is represented here. These equipments are from the building of Politecnico, and at the bottom you see some of the results. And this is part of the activity carried out in cooperation with the CI Microelectronics. So we also have another initiative, which is, the channel emulation. The channel emulator is in the bottom, is provided by Keysight, and we also have some, software-defined radio unit and some controller. And all this setup is replicated now in two cities, which is the city of Milan and the city of Bari, and is expected to replicate another city, which is Matera. So this one is what we call federated lab. So the federated lab is split in 3 different cities. In Milan, we make the channel emulation for a vehicle. In Bari, there is NTN, and also Matera is integrating a little bit. So of course, this one is this federated lab is open to new cooperation, which is part of this discussion to illustrate and open this lab to other partners. So we also now created, in cooperation with the Politecnico Torino, we also created this digital twin for V2X that we named, Van Twin. It contains the network simulator in discrete event, which is NS3, and integrated with the vehicular part, and also with the ray tracing to make a real ray tracing or realistic ray tracing with Strona. And we have a Sumo as for vehicle movement and so on. So, some more details at the bottom. So, we also have a propagation part. We also have a couple of experiments ongoing still on our roof. You see here the roof with several, devices, and we have a link with, 300 meters and 800 meters with different bands, and also free space optics with a couple of wavelengths. So, on the prototyping side, prototyping, just to enter into the WiseNet lab, we have been talking about the WiseNet lab. WiseNet lab is this, approximately 140 square meters is indicated here. And, we have several instruments that we have been acquiring thanks to the Restart project, and some other facility like the anechoic side and so on. So let's see what we do typically. We use the lab for calibration for the array. We use the lab for, anechoic, the anechoic room for other experiment. We use for testing the active metasurface, active race, or conformal one that we designed here at the bottom, or testing high frequency filter, as you see in this picture with the vector network analyzer. So more, we in the lab, we also have the V2X part at the millimeter wave radio. So, this one is the prototype of the car. Instead of car, we took, this robot. This robot contains a board. You see this gray box, which is you see open here. This gray box contains the FPGA that is on every vehicle, and then a mini PC. There is a LiDAR that you see a picture here, and some instruments on the right side when we test it, and we need to tune it, all the hardware before testing. Within 6G1, we also are building a massive MIMO connectivity, which is we have a layout represented here is 64x8 element that make all the communication in near field. So it means that we want to make the two vehicles moving. The two vehicles are represented, the two drones, two robots here. And we want to maintain the alignment regardless of the movement of the vehicle itself. And this project is in cooperation with ADAT. ADAT is SME in Italy. So we are also active in FR3. So in FR3, we have this board that was produced thanks to NTIA finance support, P radio, NYU, and FIU. So, this board is 2 input and 2 output. And so is able to control 2 antennas at a time on TX and RX. So P Radio is a startup that we made a test together with a startup and IEEE WCNC recently in a few weeks ago. And there is also new features that we plan to test with this in this setup. We plan to test the massive MIMO and others. This is planned in the near future. We also tested, the configuration of the multiband. So this is an example of multiband configuration where we test a different frequency for sensing, and we believe is a nice way to go. Where in FR3 is a nice way to go in very interesting results. So we want to expand from that. We want to go from 2x2. We want to go from 2x8. So we are now building an array with 8 antennas in TX, 8 antennas in RX. And you see illustrated here, we have some boards, and there is a exciting board that is controlling all this part. And, the element is represented here. Some results are represented there. And this is a work in cooperation with Technica, Smarty, and Polimi. So we also carried out some experiment in Isaac. So this one is a synthetic aperture experiment. This is an experimental facility in this part. So we use a car, one of the car of the department that we equipped is experimental car. Is used for many experiment. Is equipped with a radar, with a navigation component, with a video, and so on. So the goal is to make a synthetic aperture. Synthetic aperture means that when you move the antenna, you create a virtual antenna, which is called synthetic aperture itself. So this one is the image that you see from a radar when it is mounted almost in front, and this one is the PI of the project. And you really don't see, but when you make it move it, well, the resolution is growing, the azimuth resolution is much increasing, and you see a lot of details, including the leg of Stefano here in front. So it's very challenging, and it's very, interesting aspect. So within the restart, we're also working on ultra UAV synthetic aperture radar imaging. So I have 2 drones here represented here. One is here, one is over there. And so, these drones are being equipped with a radio setup, with a sensing setup that is illustrated there. And here is on the bank when we tested it. And this on the upper part, upper right, you see the target and the output, the outcome of this experiment. But there's another interesting aspect is that it has been tested for checking, for estimating and detecting any buried object or person, under the snow. So the testing is in progress, but it's very encouraging. There is also a very deep, there is a very deep expertise on sensing. And so these are some experiments that we carried out with a couple of sensing and TRX units. So it's illustrated there. And we compare one another, and these are the images that we get in real time when, you know, there are some vehicles that are passing down. We developed an algorithm which is called dual domain for Isaac, which is a particular waveform. And, you know, beyond the theory, we also tested in a realistic environment. And, you know, this one is a setup. This one is the environment, and this one are the result in Doppler and delay. So Doppler is also range. So you have a T1, which is a target that's a static, and MT1 and MT2, which is a moving target with a different speed, the speed that you can see meter per second on the top. So this one is the last experiment we carried out as a sensing, is a multistatic Isaac. Well, multistatic Isaac means that we have two vehicles. If you remember the radar mounted on the vehicle that you saw before, think about couple. And then the goal is to detect the distance between the car and the vehicle, and if there is a person really. So, you know, this one is a setup, and if one vehicle is transmitting and receiving on itself, is a monostatic, 1-to-1. 1-to-2 is a bistatic, means one is transmitting, two is receiving. 2-1 is two transmit is receive, and 2-2 is two transmit, two receive. So from the quality of the image, it's very bad, but if you compare with the coherent fusion, well, you know, you really see the very high details, like, you know, the 40 centimeters of the leg of the first of the you know, of Dario that is there, and also the corner of the car. So this one is a very extraordinary result that we got, and also is a very good balance between theory and, you know, and experimenting part. So to conclude, you know, I mean, I'm very happy, and also as a PI of the project, I'm very happy to coordinate an excellent partnership between industry and academia. You know, it's a lot of activity, a lot of work. And I'm very happy that, you know, the WiseNet, the start of WiseNet is a lab that is open to other partners of the project, but also, you know, we want to open the, you know, to other partners, perhaps, you know, within Europe. So any question, you know, you can also contact me. Thank you all.
Thank you, Umberto. We will have, of course, some time for questions at the end. So we move now to the third and final presentation. This is by Piero Castoldi, Scuola Superiore Sant'Anna in Pisa. And Piero will present you the activities of the lab on pervasive and photonic network technologies. So Piero, please.
Yes. Thank you.
Oh, we can see your screen now.
Yeah, okay. Just make the adjustment for switching the screens. So you should see
great.
full screen now. Right?
Yes, please go ahead.
Thanks a lot for the introduction, Antonio. So I'm Piero Castoldi from Scuola Superiore Sant'Anna. I will describe a few research platforms for optical communication and networks, a couple of labs, and some results that we obtained within the Restart program. So let me first mention our institute. So it's we also have an historical building, but this is the place where actually technical activities takes place. It is in Pisa, in the CNR area, very close to the other lab of managed by CNR. Is the Institute of Telecommunication, Computer Engineering, and Photonics. So as a PI of basically the project that gathers most activities on optical networks and components within the Restart program. I like to present you what is the architecture that we are focusing on. And basically, it covers the entire value chain of a typical telecommunication scenario. So ranging from the terminals through the disaggregated access, the metro, the core, and the cloud edge component. It's important to highlight all these segments because optics is going to take place and to have an impact on the different segments and components of a global telecommunication scenario. So the goals we are tackling by developing optical solution starts from the energy efficiency aspects. Let me remind that this is one of the most important objective of Restart, and this can be attained with the new generation of photonic integrated circuits. In addition to this, there are segments that also, because, for example, having the base station disaggregation are calling for enhanced capacity that we are tackling on different short and medium and long-term scenario. The optical data plane is not so stable like electrical networks, so we have telemetry and monitoring platforms. And being an optical network, still a network, as we have seen, it needs different types of automation, but it needs automation. And so we also aim for zero-touch operation. This is synergic with Super Project. And we have also a grand challenge that gathers together the different development of novel optical solution. Let me also mention a couple of synergic EU projects, the Desire 6G that is part of SNS and the Allegro project. So the lab, the Phonet Lab, that has as a motto connecting value chain of photonics, it is actually representing the different segments and components of nowadays optical network that is starting from smart terminals, so droid emulating autonomous vehicles, humanoid robots, everything of course connected, smart cam, drones and telepresence devices. Of course, we are not doing research on drones, but we want to show the effect of what is the optical networking on the final user. The disaggregated access is the segment where we deploy optics in front haul, back haul, and mid haul segments stemming from the BTS disaggregation. The metro segment, we have a number of routers of different vendors, also high performance switches with smart network card interface. Regarding transponder are being substituted by digital coherent optics, so pluggable transceiver. And in the core network, the devices emulating the highways and representing the highways, so optical add and drop multiplex. A number of equipment for making extensive network measurements have been also purchased on the Restart project. And let me conclude with the cloud edge continuous comprising different servers from different vendors and DPU data processing unit like Bluefield providing GPU on board of the smart NIC. So this is quite extensive capabilities that we deploy with a mission that is focused on demonstrating the solutions for end-to-end optical transport. So optical is present in the different segments. And in order to implement this, we need advanced optical systems, so the system design and implementation, and the monitoring platforms. And through this research, we can bring innovations in the area of optical network design for the different segments. For example, as reported in this figure, where each optical network line comprises different components, including amplifier, transmitting transponder, and receiving transponder. The link can be a WDM link, and whenever we create a light path comprising several links, we need to implement the proper transmission level, implement and calculate the margins and all the necessary transmission function in such a way, measuring for example, the comb of channels. They appear at the receiver side approximately equalized as the transmitter side. In this way, we guarantee that the optical network is operating in a proper way. Another area of research is about boosting optical bandwidth. Boosting optical bandwidth goes through different approaches. First is multi-band transmission. So a little bit similar to what happens in wireless. We just explore new bands, so new ITU-T bands. So classical third window, that is, for example, the C and L window is actually expanded to side windows that pose different problems. For example, for amplification, the dopant must be different. Another more medium long-term approach is the adoption of multi-core fibers, so fibers which have many cores, and each core can have the capacity of a classical single optical fiber. And of course, also this is going to pose coupling issues, so metal lenses are needed for doing this SDM coupling on the different cores. Also, another perspective that is very interesting is the hollow core fiber networks. In hollow core fiber networks, the core of the fibers is basically empty. So we can actually achieve with light, speed of light in vacuum. So this is going to reduce latency, also reduce attenuation. And in an optical network scenario, for example, for data center, this allows for consolidation, for example, of data center in a single node, because latency is reduced, because attenuation is reduced, and this brings advantages from the point of view of data center consolidation. Another area of interest is the study of how to use pluggable transceivers. So pluggable transceivers are based on digital coherent optics. So coherent transmission is now part of the optical domain, multi-level modulations. And this digital coherent optics pluggable transceiver have several advantages. First one is the fact that you can remove transponders, classical bulky transmitters, which also have a very large power consumption, and substitute them with these new integrated devices that are basically plugged into routers, and this allows to have a much lower power consumption. But in addition to this, this pluggable transceiver they normally export telemetry interfaces, and telemetry interfaces are exactly what you need in order to do a proper monitoring platform. So on the right side of the figure, you see the current typical architecture of a peer-to-peer telemetry, where basically the transceiver stream their telemetry information onto a collector point, and then let's say some intelligence is going to understand what is going in terms of signal to noise ratio, and it is doing the necessary adaptation onto the hardware. For the time being, this kind of adaptation is normally done in a node with a dedicated software module, but we can expect that on the long term, and we are thinking about architectures where we can put smaller AI software modules integrated directly in the interface, such that this kind of adaptation can be directly embedded in the pluggable modules. And this can be a very powerful, interesting solution for the long term. So let me also mention the part of integrated photonic technologies, because this is very relevant in the area of optics. So photonic integration is substituting on the long term certain components that are based on consumer electronics, and one affiliated lab of Restart called Infotech is exactly pursuing the goal of covering the full value chain from the system design to the card design to the GDS to the different process in the clean room, the fabrication and the insertion of selected photonic integrated components in regular equipment of telecommunication equipment. So also thanks to the project, Restart project, we could complete, not purchase in total, but complete a significant machine for die bonding and flip chip. So allowing the possibility for putting with micrometer resolutions components on a chip, on a photonic chip, and also not on Restart budget, but we have availability also of an important machine that is a nanoscribe machine that allows basically a miniaturized 3D printing of photonic integrated circuit. And this combination of capabilities is very significant for photonic integrated device fabrication and packaging. Let me go to the final part of my talk, talking about neuromorphic photonics, because as we all know, photonics is not good for storing, but it's excellent when it can just travel. And there are areas where actually the photonics can do some kind of processing just by traveling. And I'm making here an example of just a matrix with cross points, where if the cross point can have a kind of analog coupling instead of a digital coupling, we can make a combination of rows and columns in an analog way. And if we recall what is actually the structure of a deep neural network or a deep or a simple single layer neural network, what is normally done in this kind of neural network is basically a linear combination of devices, and optics can actually do linear combination of devices of different inputs at the time of flight. So just by regulating the coupling among different lines, and so creating the weights and the summation in a time of flight and in a very native and natural way. So this is a perspective that is very interesting for doing optical neural networks. And besides the fact that this approach is really native in the physical domain, it also can reduce power consumption of for future processor for artificial intelligence. And we all know how worrying is the power consumption of data centers implementing artificial intelligence. So I conclude with this last slide about POC proof of concept from Rigoletto, frequency synthesizer up to millimeter wave based on photonic integrated circuit tunable from 20 gigahertz up to 200 gigahertz, open and disaggregated optical nodes where you can combine based on the logics of monitoring heterogeneous devices in an optical network, and the expansion into the wireless drop of optics in terms of Li-Fi, light fidelity solutions where free space optics can become a complement to Wi-Fi in certain and indoor environment. There is also a CT POC from Rigoletto that is based on multi-core fibers, having a secure channels based on QKD, and this is I think the most prominent POC because it's city-wide and it resembles a real smart city scenario, showing the potentials of space division multiplexing and multi-core fibers. So I conclude here, and I thank you for the attention. Just let me mention that most of this research is also in collaboration with the partners that I list here that I wanted to acknowledge in full, and they are the partner of the Rigoletto project and the Cascade COP. Thank you for the attention, and ready for questions, if any.
Thank you, Piero. I think that we concluded almost perfectly on schedule, so I hand over to the moderator.
Thank you. Thank you all the speakers to give us a very comprehensive view on the Restart program, starting from you, Antonio, and the programmable network platforms, experimental with generation networks, and also the research platforms that are available for optical communication networks. So with this introductions, I would like to know from the audiences if there are any further questions from the speakers. I do not see any questions in the chat yet, but maybe someone wants to raise their hand and ask some questions if they are keen, interested on some collaboration. Nevertheless, anyway, the slides will be, okay, I see hand from you, Colin.
Yes, I just wanted to ask, how actively from the Italian national programme side are you looking at opportunities at the European level to leverage the fine work you've already done?
Mm-hmm. Thank you. Of course, you know, the community that is involved in the start is really large, and you know, many of the groups involved in Restart are actively participating in the opportunities for with the new calls available at the moment at the European level. So I know several project proposal being shaped now by some of the partners. Of course, in this case we are trying to leverage for with the collaboration that we already have at the European level and trying to set up a consortium at European level. Of course, also this webinar for us is an opportunity to show, the facilities that we have, the labs that we have, and the competencies that are in the different teams in the program. So of course, we are open to collaborations. And we believe that what we have built with the Restart can be an interesting asset for future projects at European level. Of course, I just want to underline here that the collaboration with industry has been one of the focuses of Restart, and I think that also the partners, the industrial partners that we have in Restart, can be important also for extending the collaboration at European level. We truly believe that many of the companies, in particular some of the the SMEs that are part of Restart, can be can benefit a lot from the collaboration at the European level in funded projects. So really encourage people part of this webinar also watching the recording to contact us, and we can easily find the right competencies within the program for trying to fit the needs of consortium that can be created for answering some of the questions, the calls in the European level.
Thank you, Antonio. I see a hand from Shobit Agarwal. Please go ahead, Shobit.
Thank you.
Shobit, we cannot hear you well. Can you be a little bit louder?
Just a moment. I was hearing noise. Now is it okay?
Yeah, it's better.
Okay. Thank you. Thank you so much, all the speakers and everybody. Myself, Shobit Agrawal, I'm working as an RTDA under the Restart program itself. The Politecnico di Milano, the work was really interesting, and I was just wondering that since we have the propagation capabilities and we are working in the wide range of frequencies, starting from the sub 6 gigahertz up to the optical range, I was wondering, do we have any fabrication facilities present in the Polimi?
Umberto, for you.
Yes. So, with one of the tests that I quickly showed, is on a vehicle, for instance, and the goal is to let the vehicle communicate, and also test the facility for the high data rate link between vehicles. So, in addition to that, there were other tests that we carried out, for instance, with the high frequency campus, so the base station in FR2 that is mounted on the roof, that is not just on propagation experiment, but also on data rate propagation that we want to test. Furthermore, you saw some of the beta surface and repeater that we are mounting, and we want to test it if you can guarantee the service in areas that are not very well covered. So we have these are examples that we have, and we want to expand, and we are ready to expand in other contexts.
Yeah, so actually, I'm working on the RIS for different applications. Okay, and we are a little bit not having the facilities for the fabrication. Since at the end you mentioned that the YZNet is open for the for the restart part. So
Yeah.
I just want to know how can we approach you for the fabrication. I mean, our designs are in the range of micrometers because they are above 300 gigabytes. Okay, and the substrate materials that we are using are currently quartz and polyimide.
Okay.
So will that be possible for us to?
Why not? Can you do you have my email? And did you get it? Made a copy, or make a screenshot while I was presenting at the end, or you can look for my name. I mean, you can find out.
Yeah, sure. I'll
Send me an email. You
definitely
know, we can talk offline. Sure.
yeah, and fortunately, I'm also in the Spoke 3, which is I think Antonio is the PI of that.
Anyway, if you contact Antonio
Okay.
or me, it's
Sure.
okay.
Sure. Okay. Thank you so much. Thank you so much.
No,
Yeah.
no
Thank you.
problem. Amen.
We have the next question from Dr. Hassan. Please go ahead. We cannot hear you, Hassan. Can you be loud?
No, it doesn't work.
You're muted. Now your speaker is open, but try speaking. Okay, we
No.
cannot hear you. Maybe you want to drop the question in the chat. In the meanwhile, I also request all the speakers to share their slides and include their email ID right on the front so that when we upload it on the event page, everyone gets your contact details and then it's easier to contact. And
Sure.
for all the audiences, I mean, the recording of the video will be available on the event page. So feel free in some time to look at that.
Can you hear me now?
Okay. Yes,
No?
we
Yes.
can hear you now.
Oh, okay, very good. Yes, thank you very much for organizing this event. This is very interesting. I'm Hassan Osman, Configuration Manager at Real Wireless, a wireless-based consultancy company. Just a question similar to the first one that was asked. So in terms of collaborating with a UK-based company, with the industry in the UK, what are the means and the ways to do that? Is only EU-funded project, or there are other ways to be able to do this?
Oh,
Antonio, do you want to answer?
well, I of course, I'm not the expert of all the rules, but as you know, there are the rules of the European Commission for initiatives associated to the calls that we have at European level, and of course, there are some restrictions for companies from UK to participate. I don't know the details, but as far as I know at the moment, I don't think there are possibilities of a direct participation, but I don't know the details. Again, I'm not the expert of the rules.
I think
Can I
Colin
maybe
wants
step
to
in
add.
here?
Yes.
Because I don't know
Yes,
if I'm
yes,
an
please.
expert,
Yes,
but I can
please.
certainly answer it. So absolutely, the UK is a full partner in SNS JU. Everything is open to you. So the most obvious way would be look at the possibilities within SNS JU and work together there with Italian partners. So that makes the most sense. Clearly, there's also the possibility of discussing bilaterally. So I don't know if there are any bilateral collaborations between the UK and Italy. There are with some countries, I think.
Yeah.
Okay, then I would suggest that the European angle would be the best one. As I say, now the UK is a full member in Horizon Europe. There's nothing standing in your way to do that.
Okay, thank you.
Thank you. There is a question regarding the slides in the chat. We cannot hear you, Poya.
Mattia, in a day or two, the slides will be uploaded and the recording will also be there on the event page. Feel free to look maybe by end of the day tomorrow. So you will find everything there. All right. So thank you once again for all the collaboration. And until the next webinar, take care and see you next time. And don't miss to visit the event page for more information. Take care. Have a nice afternoon. Bye-bye.
Bye-bye.
Thank you. Bye.
Bye.
Thank you.
Thank
Bye.
you so
Thank you so
much.
much.
Thank
Bye.
you.
Yeah.
Goodbye.